Good morning, everyone. It's 11:10, so let's get started. I'm going to talk to you today about custom resource definitions, one of my favorite parts of Kubernetes. And I'm James Bose. I'm the technical lead at Manifold. I'm going to get my promotion out of the way up front. We're a marketplace for cloud services. And my clicker's not working. There it is. Here we go. So several months ago, we migrated to Kubernetes, and I want to tell you a bit about the process that we went through, the pain points that we hit, how we sort of got around them, and hopefully it's something that you might be interested in and you can use as well, if you're going through migrations or just sort of experiencing these things yourself. So we started with a fairly typical setup, right? We had a monolithic application, and we had an infrastructure that matched it. A single auto-scaling group that ran multiple instances of this application, one load balancer in front. So we started off at least in a better place because we had already began with containerized applications, right? So it was, we had an AMI that we built, and then we'd use Cloud Init to sort of inject whatever instance of the container image was sort of the latest build. And then we had sort of some secondary containers that were like pre-configured to always be a part of the deployment. So like for logging and monitoring. But of course, we start building more, and we get a more complicated architecture for our system, right? So we've got more features we add in as new services, right? And take some of the existing architecture and sort of features and pull it out into different services. And this was great for the application level, but like as we heard sort of earlier today, having a service where you've got like one container per VM, and then we've got like tens of load balancers, it's just not great, right? It was expensive, it was slow to deploy, and we sort of had this large mess of configuration management for the infrastructure level. So we began, like I said, with a pretty simple setup where we had Packer building our AMIs to start with, and then we used Terraform for like everything from setting up DNS to setting up the auto-scaling groups and actually running the deploys as well. So we could do, you can just do like blue-green deploys with Terraform when you're using auto-scale groups. And then some good old shell script for sort of gluing together a bit of the AMI layer, where we've got to run some commands on sort of on startup of the machine. And so we moved over to a setup that was just Terraform and Kubernetes with using kops to sort of set up this, generate all this Terraform for us. So we had kind of like reduced the number of moving parts we had to use, even though there was not much bash. But you look at like a lot of the examples and everything for Kubernetes, and you see the manifest files, and it looks a lot like configuration management, right? So you're thinking like this is what I want to use, right? And especially with all of these sort of secondary projects in the larger ecosystem, you can control a lot more than just sort of your application code in your cluster, right? You can configure SSL certificates and DNS, and so you're doing all of this through Kubernetes manifest. So we had this all set up, and we had what I thought was a pretty good architecture, right? Now we've got this separation where we've got a layer just sort of for the cloud provider, which is mainly Terraform, and then arguably sort of some manifests that we deploy with kubectl, right? Where things like DNS and like SSL certificates, you could say, okay, this is sort of the base layer. And then we had our Kubernetes layer, right? Again, sort of a mixture of both, and arguably, like the way I see it, some of our namespaces are sort of cluster level. And then the application level, which was just manifest, right? So no more having to do Terraform apply and sort of rolling out new auto-scaling groups when we did a deploy. And this was awesome because it's a lot faster since we don't have to wait for these machines to boot. But what we started to see was that, if you look at all of these services that we have that are very similar in structure, everything has an actual service, right? It has a deployment, and most of them have ingresses since they're publicly facing. And the only thing that varies, we've also got similar environment variables, right? Sort of base setups. Since we've written all this code and we've written it using the same language and frameworks, they all sort of expect the same inputs when they start up. So they're all very similar with just slight differences. Maybe one or two different environment variables. This one's talking to a different database than this one. Obviously, sort of the actual container image is different between them. And then we had them repeated across, come on, Bluetooth. Repeated across a lot of environments, right? So we had our stage and our prod environment, and we have a dev setup as well. So we've got like 3 different directories that all have the same YAML for all these applications that also sort of have similar groupings of YAML. And it's a lot of copy paste, and it's it's a lot of copy paste, but just with slight differences, right? So it's a great place to make a mistake, right? Copy over this one and forget to actually bump the version on your container image when you go to prod or whatever. So we had taken our complexity like from the infrastructure level and just moved it up into our application level. Same kind of repetition and sort of places to make mistakes. And I think the first mistake we made in this is that assuming that these manifests are, configuration management, when really this is what you pass into kube-control, but it's a direct mapping to an API object that exists in Kubernetes, right? This is a deployment object. And essentially what you have, and this is sort of the good part, right, is that what you have in a manifest file is then what exists in your cluster. Obviously, there's some differences about sort of the actual status and everything, but the intention is that you want to synchronize these files into the actual state. But that doesn't sort of work well for templating and for having lots of repetition. So we wanted to get away from this sort of vast expanse of YAML that we had. And we sort of looked at, all your traditional options, right? Like, are we going to bring these things back in? Am I going to have to write Ansible playbooks? Or, again, and I didn't really want to. And we looked at sort of some of the more sort of Kubernetes native things, right? Helm wasn't really working for me, right? Because I'm not looking at having a sort of simplified sort of general purpose application deployment for other people. I'm looking at having all these applications that are similar and coming like just to me, just to us. And KSonnet is appealing, but it's, fits like a similar model to some of the existing tools. So we started looking around at, looking at Kubernetes itself, right? Sort of the base thing you have is your pod. And you have multiple pods and they form a replica set, right? You have multiple replica sets form a deployment, right? As you do your deployment, you bring up a new replica set and you scale up and down the old and new. And so the pod is then this sort of base unit that these other parts build on. And the pod has existed for a long time, and sort of, different versions of these concepts have sort of been built and replaced on top of it. Additional ones are there too, right? Like daemon sets and stateful sets. And then sort of looking out wider, you look at Docker for Mac and Windows when they added Kubernetes support. And one of the sort of neat features of this was, hey, you can use a compose file with Kubernetes. And it's really just taking this compose file and sort of putting your sort of standard Kubernetes like header on top of it, getting your metadata in there, and then pushing it up through either so you could take your compose file and sort of hand add these fields, or use Docker stack and the Docker stack command and run it as well, and it'll just go right to a Kubernetes API server. And then through API server aggregation, this bounces over to the Docker-specific Compose API server, which sees this and says, okay, cool, I'm going to make this Compose object that now lives within Kubernetes. The controller sees this and then just speaks again to the API server and says, hey, I know how to understand the contents of the Compose file, so I'm going to go ahead and I'm going to make all of the components that are necessary to sort of reflect this into the cluster. So this is all happening within the cluster, right? And you could either use Docker stack or you could use kubectl to actually have this happen. And then another recent example is a Gonez, which I'm sure I'm mispronouncing, but it's a project to sort of build this general purpose tool for doing game servers by Google and Ubisoft. And so there's sort of your application specific like lobby and a client connects to this. You have multiple clients connect to this lobby or like matchmaking server. And this specific logic then says, okay, cool, I've got enough people to start a game. I've sort of paired them all up. And I'm just going to speak to the Kubernetes API server, and I'm going to say, make a game server. This makes a new Kubernetes resource. That's a custom resource definition. And the Gonez controller comes along and looks at this and sort of does the specific logic needed to then make this into an actual pod, right? And the purpose here is that they have these sort of somewhat ephemeral pods that are specific for the players in this game, and there's a direct connection to the outside world, like instead of going through a service or an ingress or anything, because they want to maintain the sort of low latency of a direct connection. So look at all these things and sort of some points kind of struck for us, right? Is that Kubernetes is all about composition, right? So taking these base components and sort of building abstractions and additional features on top of them. And the other kind of weird thing is that in some ways Kubernetes is a database as well, right? You have the API server with custom resource definitions or even API server aggregation, and it's responsible just for taking in objects and persisting them. And then there's other components that, like controllers that run, that sort of do something with this information. Either they add more into the API server, or eventually you get down to like actually scheduling pods, or you get down to creating DNS entries in like a completely different cloud service. So what we did was we said, hey, we're going to make our own custom resource definitions, and we're going to build a controller to handle this. So we're going to model our sort of specific logic around these, around our services as CRDs, and we're going to handle that template expansion in Kubernetes itself. So the recipe for this is you need a custom resource definition, you need a controller, and then you can add admission controllers to taste. So let's step through these. So some more YAML. A basic CRD, so in our case, right, we've got this application that is sort of what we call our microservice or whatever, and all you're doing is reserving a namespace. You're saying this is what this thing is called, and it's going to sort of live under my my API group. And there's nothing here about schema or the actual shape of what these look like, right? And this is how we run ours. I think it's a matter of sort of the support for that, which on the next slide is a little bit newer, but also maybe not necessary depending on who your audience is. So if you're working on a small team like I am, it's enough just to sort of tell each other like, hey, this is what things look like. So don't worry about validating on the server. But you are able to use OpenAPI schema validation to sort of enforce some of these things. And word of warning, though, is that OpenAPI v3 schema validation is a subset of JSON schema, and the flavor used in Kubernetes doesn't support all parts of OpenAPI v3 schema, so sometimes there can be some gotchas. Specifically, sort of references to other objects isn't going to work too well, but defaults as well don't sort of fit in here, and we'll come back to defaults. Anyways, it is a good place, like if you wanted to say that a policy of your organization is that we have to have at least 2 of these things running, then you can enforce that there's going to be 2 replicas. And then the next part, of course, is the controller. And if I was going to have a bunch of code on my in my slides, it would all be around this, because this is where we spend most of our time. But the idea here is that you take your application, our application definition, where we would basically say, this is the container image that you're going to use, and these are some additional environment variables. And the controller knows that I'm going to need to make a deploy out of this to actually, run the code, have a service map to this, and then include an ingress with it. And our logic here is then able to sort of take our default, a default config map we have that sort of contains the base environment variables and inject this in as well for everything. But what the controller does is it says, okay, I know that I need these parts, what exists in the system right now, and I'll just create everything that's missing, right? So this is sort of where your template expansion happens. Again, I said, this is where all the code would be, and this is the takeaway myself for this. If we were going to go back and do it again, I would say to just start with MetaController. So if you're not familiar with it, MetaController is a quite nice project that sort of wraps a lot of the controller logic and uses sort of Lambda functions or webhooks that you provide to actually give like your specific logic for it. So one of the sort of flavors of controller that you can do with this is a component controller, where you're given, like in this sort of webhook, you're given a parent and children. And so this models like that, the thing of taking this application object and expanding it out into the other resources. So your code is able to just say, like, look at the parent that's passed in and return, like always just return the children that you expect to come out of that. And if they exist already, and someone's tampered with one, but you always just sort of look at the parent and return the expected children, then everything will sort of get fixed up to the expected state. So for us, we had to worry about actually like registering listeners for all these different objects and making API calls to actually like reflect them back into the API server versus just returning a single sort of result out of some JavaScript or Python or whatever. So yeah, I would definitely like, as a first place to start, prototyping, if you want to look at doing this kind of thing, this is the place to begin for sure. So moving right along to the optional pieces, the webhooks, so the emission webhooks. So there's 2 flavors that we haven't felt the need to use yet, and I think a lot of this comes down to, again, sort of team size and where you need to socialize these values. But if we start with, our app coming in to the API server, we can sort of, pass along to so one of the types is a validating admission webhook. So we can say, like, is this an OK request? And this is where you can implement logic that sort of doesn't fit into schema validation. So, the contrived example, you could say, you're not allowed to set the debug environment variable for production deploys. So we can check what's passed in, and if it's yes, then return a nice result with a sort of readable error. It says no, and the API server will then return this result to whoever called the API. So you can see, if you're running like kube control directly, you can see, oh, this wasn't permitted. And As an aside, this is sort of another place where you could implement some interesting, policies. Because you are able to see who made that request. So you could say something like, on weekends, only this person is allowed to deploy, and they can only deploy if it's like we're using Semver and it's just a patch version bump or something like that. So you can start to do sort of some more advanced, policy enforcement. The other type is a mutating admission webhook, where you're actually sort of able to take the full object that's come in and modify it. So if you did want to use defaults, this is a place to implement that. For us, we just did it in the controller, because we're only expecting our controller to actually read these objects. But if you implement it sort of as part of a webhook, then once it hits the API server, it already has these values like in the resource itself. So other controllers that may be doing different things can actually read them as well. So why? Why would you want to go down this path instead of using, Ansible or Puppet or Chef or anything else? For us, it was because we didn't want to bring in an additional tool, but we did want to get rid of all this duplication. And the CRDs exist already, right? This is something that we were able to build on top of. So, some other points though. If we look at like how an Ansible deploy would work, like you start with sort of the template or the playbook on your system, and then you expand it out there into these objects, and then you store all of those into Kubernetes, right? And then if we look at what we do with these CRDs and controllers, you start with this template, and you push that into Kubernetes through the API, and then the expansion happens over there. And the critical sort of piece of that is, the famous Kubernetes reconciliation loop, right? Which you could get with something like running, if you ran a Puppet Master or whatever, you would have the same kind of periodic reconciliation, but this is running within your cluster and using a loop that sort of exists in this cluster already instead of bringing in an additional component. So this sort of prevents, some mistakes that can be made. If you delete a service by accident, the reconciliation loop, in your controller is going to see that this service is missing, whereas your sort of application CRD expects it to exist. So it's going to compare, see that it's not there, and then it's going to reconcile by recreating it. And the other thing is sort of this composability part. So this is an Ansible playbook, just a snippet, right? And running a deployment using the K8s raw module. But it's really simple to just switch this over to using your own custom resource definition. So you can take these sort of built within the cluster and then have other consumers use them, right? So if there's another part of your team that wants to use Ansible, or they want to build a Slack bot or whatever, they can speak to the Kubernetes API and they can do this. You can also build on top of it within the cluster. So there's nothing preventing you from building a CRD that is composed of other CRDs. So, we heard a bit about operators this morning, and I think that we should all sort of consider building our own operators for our own specific needs. And it's not necessarily about encoding complex logic in your controller, but just about sort of codifying the shape of your architecture. So, a few sort of points of caution is that CRDs are still relatively new, and the big potential pain point here is no multi-version support. I think and this is why the Docker example from earlier is done with API server aggregation, because there's sort of a need for being able to advance versions and do it right now. But For like internal company use, I think it's okay to, especially with something that's not sort of super complex, to just say, you know, this isn't an issue for us. If we need to have a new version of this resource, well, we'll just give it a different name, you know, and then people can use that. And we don't need to sort of worry about the migration, especially because if it's in your own cluster, then you can sort of see what exists that sort of the old versions. There's a lot of moving parts to this too, right? So talking about the actual CRD definition, the controller code, and then optional webhooks. Even if you get into MetaController, like you've got to deploy MetaController, then you have to deploy your code that will actually receive this webhook for MetaController, and then you have to deploy the configuration resource that will actually handle sort of firing this. Now, in our case, where we did write everything in Go and we use client Go, you know, custom resource definitions are just another type of API object in Kubernetes. So what we did was we packaged that up in the code, and when the controller starts, it just ensures that its CRDs exist, and if they don't, it creates them. So it was just sort of like one less thing to have to do, but you could also just, you know, deploy a YAML file. And, you know, attempts to sort of make this a little easier to do are still early. Got MetaController. KubeKit is something that a peer of mine is working on, just sort of taking some of our logic and extracting it. And then, of course, Operator SDK, you know, announced this week, which is looking quite promising for any kind of operator or sort of higher level sort of resource dealing abstraction in the controller. So anyways, I'm pretty excited about all of this. Like, I think that the extensibility story in Kubernetes is my favorite part of it. I think it has been quite useful for us. And I'm excited to see where it goes. So thank you. And we've got a bit of time if there's any questions. Yeah. Oh. Pardon me? Do you have this on GitHub? The presentation or the? Yeah, code, whatever. The presentation's up on the on Sketch. Okay. And for code, there's links in them. So for code, you can go and take a look at KubeKit. For our actual or for our organization specific stuff, I would look at examples of existing sort of controllers, because the specific parts there are sort of, you know, specific to us and not super interesting. Cool. Yeah.
Can you elaborate why Helm wasn't a good option? Like having a standard template as your applications are more or less the same, and having a standard template where you define things like the image that you're going to deploy.
Yeah, so why wasn't Helm a good fit? So having a standard template, right? With Helm makes it simpler to sort of modify your this single application, right? But we're talking about many applications, so it's really like kind of a trivial difference. And I think that you could even begin with Helm. Actually, I think they do complement each other quite well. Is to start with Helm and say the things that I'm manipulating sort of on my laptop, I make those simpler, and then have more of this logic in my cluster for performing reconciliation.
Thank you.
Hey, you're welcome.
Question there?
Oh, yeah, one more question. Yes?
So then, all the interactions I've had with Kubernetes works well when you're calling the API, right? And that is fine for the programmatic CI/CD kind of approach where you expect an upstream service to make it call.
Mm-hmm.
But I think a lot of the bigger CI/CD systems and large companies do it in a much more event-driven type basis, where something happens, like a push to a registry or something else, and then you want Kubernetes to kick in. So then you have to start with a lot of webhook type stuff, and then you add an entire glue layer. I don't know how, or if you've run into this problem before. Kubernetes doesn't have a good watcher architecture yet.
Kubernetes doesn't have a good watcher architecture. And implementing this sort of with some CI/CD parts to build a pipeline. I think that for internal uses of Kubernetes, the watcher architecture is actually really great. But that's for listening to internal changes to the API server. For receiving events, Brigade, like some of these sort of workflow-driven things, I think are good options for that, but I've not done anything with them. Cool. Yes, you.
So when you started working on the controllers, you started with MetaControllers? Or how did you work that out?
When we started working on the controllers, did we use MetaController? No, we started with Client Go. So yeah. And that, I mean, it has a lot of nice primitives for building controllers, right? That's sort of its purpose, along with being a client of the Kubernetes API. But it is relatively low level, so we had to write, several thousand lines of code that was, if we had written it with MetaController to start with, it would have been on the order of tens of lines of code.
So if I want to start from scratch, MetaController would be better?
If you want to start from scratch, yeah, go to MetaController for sure.
Because I found, yeah, maybe no operator. Because what they have on Kubernetes, they have like some scripts, and those scripts create a lot of code to just start up with their controller.
You found that there's a lot of code generation. Yeah.
Before you can actually start doing something.
Yeah. So it can be a bit daunting to get into. A lot of the MetaController examples are just sort of single JavaScript files, and the logic, the sort of the workhorse of it is happening within MetaController itself, and you're just able to say, yeah, I want to create a deployment, and just go ahead and take care of that for me, MetaController. So, and that begins to feel more like templating versus writing code. Cool. Okay, I think we're out of time, so any more questions, we'll just take them offline here. All right, thanks everyone.